In this worksheet, and this is worksheet number 8, we're solving the square root equations. And so notice that in the first two problems, there's only one square root expression. So you see one here and then one here, one square root expression. That's the easy kind. Now let me go ahead and write number 1 over so I can have enough room to where I may want to say some other stuff. So I have this square root equation, and the first thing you want to do when you have a square root equation is to get the square root by itself. So get the radical expression by itself, and this already has the radical expression by itself. And so I'm going to go ahead and rewrite this over. Now the next thing you do when the radical equation is by itself, you want to get rid of that square root symbol because you just want to get the radicand by itself. And so the opposite of square rooting is to square. So I'm going to square both sides. But what I do to one side, I do to the other. And so remember, this right here is being multiplied by itself twice. So remember when we talked about something like this where we had the square root of 5 times the square root of 5. We all know that's equal to 5, right? Because 5 times 5 is 25, and 25 is a perfect square, which means the square root of it is 5. So if I have the square root of, let's say, 6x times the square root of 6x, you know that that is 6x, right? So if I have the square root of x minus 1 times the square root of x minus 1, then that's just what? X minus 1. So if I have, right here, if I have the square root of 3x minus 2 times itself, square root of 3x minus 2, then it's just the radicand, 3x minus 2. So that pattern exists. And so all I need to do now is just see that, hey, the square root and the square are inverse operations, so they undo each other. And so you just get 3x minus 2. And on this side, 5 squared is 25. And notice I went from a square root equation to a linear equation. See, this is now linear. And so to solve this linear equation, you just got to get the variable by itself. So you're going to add 2 to both sides. And so when you combine like terms, you get 3x, and 0 is just 3x, equal 27. And then dividing both sides by 3, I get 3 divided by 3 is 1, so 1 times x is x. So I get x to be 9. All right. Now I'm going to say this. Since I raised both sides to an even power, when you raise both sides to even power, you should check your solution. Especially in the next worksheet, worksheet number 9, where you're going to get extraneous roots, and you're going to see why. But to be on the safe side, whenever you raise both sides of an equation to an even power, you need to check. Now, in these problems, you won't have to because on the other side, when you get these radical by itself on the other side, that's always going to be a positive integer. So it's always going to be a positive real number. Let me put it that way. A positive real number. All right, so you really don't have to check these, but in the next lesson you will, the next worksheet. So if you check it though, let's go ahead and check it. So let's just check this. So if I check x equal 9, you go back to the original problem. And here is the original problem. Square root of 3x minus 2, and that's equal to 5. So wherever you see the variable x, I'm going to substitute 9. So I get 3 times 9 minus 2, and I want to see if that's going to equal 5. That's the question. Well, 3 times 9 is 27, so I have the square root of 27 minus 2. The square root of 27 minus 2 is the square root of 25, and yes, indeed, that is equal. Square root of 25 does equal 5. So that's a solution. All right. Number 2, we have, number 2, there's number 2 right here. So we have this. We have some of those like this. We have the square root of 5x minus 1 plus 3 equal 8. Now remember, you must, the first step when solving a square root equation is to get the square root expression by itself, to get the radical by itself. So it's not by itself here. See, I'm adding a 3. So I got to subtract 3 from both sides first. And so I get the square root of 5x minus 1 is equal to 5 again. All right, and just like we did this one, you're now going to get rid of the square root symbol by squaring both sides. All right, so when I square both sides, remember what this says right here is this, the square root of 5x minus 1 times the square root of 5x minus 1. So when you multiply two square roots and the radicands are the same, it's just a radicand, 5x minus 1. So again, basically the square root and the squaring are inverse operations, so they undo each other. So you get the radicand, 5x minus 1 equal, and then 5 squared is 25. So notice again you have this linear equation. So in this worksheet, all of these square root equations will end up being linear. Will lead to a linear equation. So if I add 1 to both sides, I get 5x, this is 0 right here, equal 26. And divide both sides by 5, I get x to be 26 divided by 5. All right, now if I, and again, to be on the safe side, check this, because I did raise both sides to even power, but in reality, you really don't need to check these, because when you rewrote the problem, you got the radical by itself. If you look at what was on the, you see the radicals by itself, but when you look at what's over here, you did not have a variable. You did not have a variable, and that's a positive real number. So this should work, unless you made an error somewhere in the process. But let's just go ahead and check it. So let's check x equal 26 divided by 5. So wherever I see the variable x, I'm going to substitute 26 fifths. So I get the square root of 5 times 26 fifths minus 1, and I want to see if that's going to equal 5. Well, remember, these 5s divide out, right? And so you get the square root of 1 times 26 is 26 minus 1, and that's the square root of 25, and yes, square root of 25 does equal 5. So that's a solution. Okay? So number 1, your solution was x equal 9. And number 2, it was x equal 26 fifths. All right, and finally number 3. So here's number 3. So number 3, we have 6 equal the square root of 2 minus 3x. All right, so notice that the radical is already by itself. So all I need to do, what's the next step I should do? What do y'all think? What do you think you should do to get rid of the square root symbol? Because you're trying to get this radicand by itself now. Okay, so yeah, square both sides. All right, so whenever you deal with square root, you're going to square both sides. And then remember though, this was a cube root. Whatever your index is, if this index is a 3 or a 4 or 5, that's what you would raise it to. Okay, so these undo each other. The square root and the square are inverse operations. So I get 2 minus 3x equal, and then 6 squared is 36. Now again, make sure you understand what I had before. So I had the square root of 2 minus 3x times the square root of 2 minus 3x. So I'm multiplying 2 square roots. The radicands are the same, so it's just a radicand, 2 minus 3x. And that's what you see here. Okay, so notice this is linear. So I'm going to go ahead and subtract 2 from both sides. So I get 34 equals the negative 3x, that's 0. Divide both sides by negative 3. Negative 3 divided by negative 3 is 1. 1 times x is x, so I get negative 34 thirds. Okay, and let's check it. So let's go back to the original problem. Always go back to the original. So 6 equals the square root of 2 minus 3x. All right, so where I see the variable x, I'm going to substitute negative 34 thirds. So the question is, 6 equal to the square root of 2 minus 3 times a negative 34 thirds? Well, these 3's divide out, right? And so what I have here is this. If I look at the radicand, I have 2 subtract 1 times a negative 34 is a negative 34. So 2 subtract a negative 34 becomes the square root of 2 plus 34, which is the square root of 36, which is 6. And 6 does equal 6. All right, so that is the answer to number 3. So in number 3, we have negative 34 thirds, and that is the key to worksheet number 8.